It's time to talk about some parallelogram properties. So, what we're going to do here is first talk about the 5 main properties of a parallelogram. A parallelogram is quadrilateral. By definition, its opposite sides are parallel. So, both sets. So, when you say opposite sides, that means the top is parallel to the bottom and the left is parallel to the right. Now, that is what a parallelogram is by definition. And there's going to be multiple types of parallelograms. Another thing is that the opposite sides of a parallelogram will always be congruent. So the top will be the same length as the bottom, and the left will be the same length as the right. Okay? Opposite angles are congruent. So the top left angle will be congruent to the bottom right angle, and the bottom left angle will be congruent to the top right angle. So the opposite angles are going to be congruent. Now, the next one, same side angles are supplementary. So that means the two angles on the top will add up to 180. So if this guy was 100, we're just pretending here, this guy would be 80. And if you look over here, this guy is going to end up being 100 for 2 reasons. Well, it's on the same side, so same side angles are supplementary, and opposite angles are always congruent. So again, the 180 can be different. That's just to show you that they are supplementary. Finally, the last property is that the diagonals bisect each other. Now, the diagonals are not drawn in here yet, but if we did have diagonals, that would go from corner to corner, obviously. They bisect each other. That does not mean they are the same length. So if the diagonal from the top left to the bottom right was 10, it would be split to 5 and 5. So when we say that they are congruent, that means this piece is congruent to this piece, and this piece is congruent to that piece. So the diagonals themselves are not the same length, but they cut each other in half into 2 congruent pieces. All right? So those are your 5 main properties of a parallelogram. So I'm guessing you can figure out what's next. We're just going to apply those properties in different ways. So these first 3 problems are just listing information based on what we have. So in the first example, we can just look at all the given properties and we can just start answering questions. So we know that BM is half of a diagonal. Well, if we know this half of the diagonal is 14, then BM is also going to be 14. AC. Well, we see that AC is a full diagonal's length. So the full length of the diagonal means that this piece is 9 and this piece is going to be 9, so AC is going to be 18. Finally, we're looking for BC. So BC is the right side, and remember, opposite sides are congruent, so it's got to be the same length as the left side. Last is our perimeter. Well, we already know this is 10 and that's 10 and this is 12. So since opposite sides are congruent again, the bottom is going to be 12. So our perimeter is going to be 44. Okay, so that's just an easy problem just using what we know about parallelograms. The next example has interior angles. One thing we know is that opposite angles are always going to be congruent. So y is going to be 120 degrees. And then x is not 120. Remember, angles on the same side, so both angles on the left side or both angles down here on the bottom are going to be supplementary. So no matter which way you look at it, x is going to be 60 degrees because they have to add up to 180. Now the last one is a little bit of a puzzle. You're going to use everything you know about angles inside of a parallelogram to find the measure of all of these missing angles. And a lot of that's going to go back to what you know about linear pair and triangles as well. So right here, we're going to start in the middle. You don't have to do these in numerical order. So we know that vertical angles are always congruent, so we know that angle 8 is going to be 100. We also know that a linear pair adds up to 180, so these guys over here are both going to be 80. So we just found 3 angles in the middle of this right off the bat without even thinking about parallelogram stuff. So we know this is going to be 80, 100, and 80. Now we can start thinking about other things we know. Another thing that we know is that triangles will always add up to 180 degrees. So in the top triangle, we know that this guy is 100. We know that this guy is 50. So that means angle 1 has no choice but to be 30 degrees. And we can do that exact same thing on this left triangle here. This is 80. That's 40, which is 120, which means we are missing 60 degrees for angle 6. So how are we going to find the rest? Well, remember, the key is that this is called a parallelogram. So we do have parallel lines, and in this case, we also have transversals. So angle 1 is going to be congruent to angle 5 because of alternate interior angles. So we know angle 5 is going to be 30 degrees. And we also know that angle 40 is alternate interior with angle 2. So we know angle 2 is also going to be 40 degrees. And now you can finish angle 3 and 4 in one of two ways. You can just use alternate interior angles again and say that angle 4 is alternate interior with 50. Or you can just use triangle sum 180 for the missing angles as well. So 40 plus 80 again is 120, so angle 3 has to be 60. So it's just a little bit of a puzzle using everything that you already know about triangles and parallel lines and vertical angles and linear pair. These two are algebraic based problems. So again, this requires you to know all of your properties. So the first thing we're going to do is we're going to look at what type of angles we have here. Now, these are not opposite angles. These angles are on the same side. They are both on the left side over here. So angles on the same side are supplementary. So what you're actually going to do is you're going to add both of these angles together and set it equal to 180 degrees. So 10x is equal to 150, so x is equal to 15. Now that we know x is 15, we can find the measure of angle A by finding its opposite angle or its same side angle. It really doesn't matter which way you want to go. Since it's easier to just find the measure of an angle once and just be done with it, we would plug it into the opposite angle because we know opposite angles are congruent. So we just multiply 15 by 8 and add 20 to it, and we are going to find out that the measure of angle A is going to be 140 degrees. And that's it. Last question. We are going to find x and y. We are actually only going to find y at this moment because we are missing some information. I forgot to tell you that AC is equal to 20. That should help. So, to find y, we know that diagonals bisect each other. So we're just going to set 3y minus 6 equal to y plus 10. So that's going to give us 2y is equal to 16, so y is equal to 8. Now to go back and find x, now that we have enough information, remember, diagonals are cut in half. So if AC is 20, then that means each of these pieces is 10. So you're just going to set 2x plus 2 equal to 10, and that's going to give you 2x is equal to 8, which means x is equal to 4. All right? So that's it for all of the basics. Now there are two more challenge problems, and these problems I will let you try on your own. You can bring them to class and see if you got them correct, but I will give you one clue. Systems of equations. You will need to know how to use systems of equations to solve both of these. All right? This is Longo, and I'm out. See you. Bye.